Welcome to the lecture on confidence interval. Confidence interval is widely used concept in many of the research fields. Let's consider what is confidence interval. And I must recall that the lecture number 26 on words, please watch in sequential order. So this is the fourth lecture of this specific lecture series. As I mentioned in the previous few lectures, this is the population distribution where we have mean at the center. We call the population mean mu and plus 2 sigma minus 2 sigma, which are the standard deviation of the population. Under this curve, we have the values of individuals. Assume that this is birth weight of newborn babies. If we know the total population mean, there are individuals who have high birth weight and the babies with very low birth weight. And middle, the average birth weight babies are here. We take many samples from this population and we draw the sampling distribution here. Ideally, this must be very small one compared to this one. So I will erase this one, the population distribution. Ideally, the population distribution is more dispersed than this one. So it should be something like this. In this sampling distribution, we have mu x bar at the center, or the mean of the sample means. And we have 1.96 SE, standard error here, and standard error minus 1.96 standard error. We know that the standard deviation of the sampling distribution is standard error. Now, let's consider few points here. Okay, I told you that these are sample means of the birth weight of the babies. Assume that the average is 3 kilograms and standard error is 500 grams. So, two standard errors will be approximately, here it should be slightly less than 4 kilograms because it is 1.96. 2 equals 4 kilograms because standard error equals 500 grams. So here almost it should be near the 2 kilograms. Okay, now think about one sample here. We have a sample where the mean is x bar 1. I told you, under this graph, there are so many sample means. In general, we don't know the population mean, this one. We don't know that one. So, we know that this is here and we can calculate standard error. Assume that the mean here is 3.2 kilograms. So, the two standard errors from this sample mean will be 4.2 kilograms and here it will be 2.2 kilograms. Generally, we know that 3 plus or minus 2, 1.96 standard errors, approximately between 2 kilograms to 4 kilograms, 95% of the sample means are there. But in general, you don't take multiple samples. You take only one sample. Assume that this is the sample where the sample mean is 3.2. So you can calculate the standard error by using the sample value. And if the standard error is 500 grams, now we have confidence level of 2.2 to 4.2. Assume that we will take another mean which is x bar 2. Assume that this is the value is 2.8. So 1.8 kilograms to 3.8 kilograms is the limit for this one. Now you can understand that depending on the sample mean that you are taking, we have different intervals. How many intervals that you can make? Of course, you can make infinite number of intervals like this. We call these intervals as confidence intervals. Why infinite number? 3, if the mean is 3 kilograms, you can create another interval. If the mean is 3.1, another interval. If the mean is 3.11, another interval. If the mean is 3.111, another interval. Infinite number of intervals. Out of those intervals, for all these means, you can create this kind of intervals. Assume that you divide this total into 100. So look at these intervals. Now, among these intervals, all these intervals will capture the true mean which is at the center. So here this interval which is from 2.2 to 4.2 will capture the true mean which is 3 kilograms. This interval also will capture the true mean. But look at if the mean is somewhere here. If it is somewhere here, x bar, this is the place, x bar, we'll call it x bar 3. Assume that this value is 4.1 kilograms. The lowest value will be 3.1 kilogram to 5.1 kilograms. This interval will not capture the true value. But you know that you have taken different random samples. Of course, all these samples are random. Because of that, we created another normal distribution. And all samples are normal. All these samples are representative. But some have values more close to the true mean, some have bit far away values. Out of all these means, 5% of the values or 5% of the sample means will be in this range. So, out of the 100% or 100 intervals that you can make, 95% of the intervals that you create will capture the true mean. But 5% of the intervals that you create through this sampling distribution will not capture the true mean. So, how do you interpret this confidence interval? Confidence interval says that in relation to this sampling distribution, 95% of the intervals will capture the true mean, even though all the samples, assume that there are 10,000 sample means here, even though all these 10,000 samples are random and representative samples, out of those 10,000 samples, 95% of the samples will capture the true mean and 5% of the samples will not capture the true mean. But generally, how do you interpret? Generally, we don't have all these values, we have only one sample. Our confidence interval, we can assume that our mean is 3.2 kilograms and standard error is 500. So the confidence interval, of course, this confidence interval is 95% as we are interested in minus 1.96 to plus 1.96. So 95% confidence interval, approximately it will be 2.2 to 4.2. Of course, that is mean plus or minus 2 standard errors. Generally, we interpret this, we are 95% confident that the true mean will be in this range. That is how we interpret in general. And some people interpret it like this. 95% of the sample means will be in this range. But keep in mind, the two things I mentioned, I recall again, we are 95% confident that the population mean will be in this range, or the other one, 95% of the sample means will be in this range. Those are the common methods of interpreting the 95% confidence interval, which are wrong. Actual thing is 95% of the intervals that you make will capture the true mean. What will happen in practical setting? We don't know this kind of 10,000 or 100,000 different samples. We have only one sample, so which is this sample, where the mean is 3.2 and we have the confidence limit which is 95% confident limit, which is 2.2 kilograms to 4.2 kilograms. Assume that this is our sampling distribution where the mean is at the center, and out of the 100% of the intervals that we can make, 95% of them will capture the true mean, and 5%, 2.5% at the lower part and 2.5% at the higher part, those 5% of the intervals will not capture the true mean. So how do we interpret this? Assuming that our sample is random and a representative sample, this interval, what is this interval? If we think about the probability wise, this is a random sample. So this interval has 95% of probability of becoming one of these samples with the probability of capturing the true mean. So this interval is A. So the mean is 3.2. So A bar. So A bar, theoretically, it can be anywhere here. But 95% of probability is there to be it in between this range. Because of that, as this interval has 95% probability of being in this range, we call that we are 95% confident that this will capture the true mean. That is exactly how we interpret 95% confidence interval. Do we only have 95% confidence interval? No, we can have any level of confidence. We can have 10% confidence interval, 20% confidence interval, but we can have 68% confidence interval. We capture mean plus or minus 1 standard error. 95% that we discussed, mean plus or minus 1.96 standard error. 95.5 or 95.4, mean plus or minus 2 standard errors. 99%, 99.7% confidence interval, mean plus or minus 3 standard errors. But in statistics, in most of the subjects, we use this 95% confidence interval. I will tell the reason in the next few lectures. What about 99%? Assume that in the previous example, your mean is 4.4 kilograms. So, mean plus or minus 3 standard errors will be, as the standard error was 500 grams, so it will be 2.9 to 5.9. This has captured the true mean. So you have the question, why we always go to 95%, but 99% or 99.7% will easily capture the true mean. Because this consists of 3 standard errors, where easily we can capture the true mean. But you need to capture one fish in the lake. To capture, you can use very small net. You have not wasted your time, you have a small net and you capture that fish, which is very efficient. Or else, you can take a very large net where we can capture that fish very easily. Or else, you can remove the total amount of water in the lake and you can easily capture that fish, which is not efficient. So that's why we go for 95%, which is efficient than this one. So I will summarize the content of the confidence interval. As I mentioned you, 95% of the intervals out of the whole infinite number of intervals that we can make will capture the true mean. That is what is called 95% confidence interval. But these are the routine explanations. 95% confident that the true mean will be in this range, which is wrong but we can consider this statement as correct because of there's a 95% probability of capturing the true mean by our random sample. Because of that, we can say that's 95% confident that the true mean will be there. So we can consider this as true. This is also true because of this. What about this? 95% of the sample means will include in this range, which is not. This is about confidence interval.